Hello everyone. So today we are going to start our next topic of the physical geography class 11th, that is water, oceans. So water basically how it exists in our atmosphere, in our on our earth. So there are in gaseous form, in the liquid form, and the solid. So in the solid forms, as we know that they have been in the ice caps and glaciers. The water form has that those are in oceans, streams, lakes, and the third one is in the moisture, in the either in the soil moisture form, in the moisture of the soil, or in our atmosphere, the moisture we have. So, and we know that our Earth is called a blue planet because it has 71% of its surface is covered by water. What so hydrological cycles? So we have studied in our childhood that the hydrological cycle is the circulation of water within the Earth's hydrosphere in liquid, solid, and gases by the phase changes. And it is the main reason because of which the circulation of water, the flow of the river, the fill up of water by the lakes, oceans, everything works over it. So this is a very major phenomena that has been taking place to support the human life. So going first about these are the I used to add these points. This is my NCERT notebook, and I have added some of the points up or down, left, right, wherever I gets the space. So this is what I've written. The 70%, 71% of the Earth's surface is covered with water. I'm talking only about the surface. Therefore, the Earth is called the blue planet. 77% of water is in oceans. So oceans, so whatever water that has been available in on our earth, either in the form of oceans, lakes, rivers, glaciers, atmosphere, whatever it is, 97% of the water is in oceans. This now the third point. Here it is written that the distribution of water in on our earth. So oceans have the highest amount of water, as we know, 97%. Then the ice caps and glaciers, and then groundwater. Remember, ice caps and glaciers has a high concentration, high water content, high water than the groundwater. Then lakes, then atmosphere, and then rivers and streams. So atmosphere has a higher uh, water content than rivers and streams. So this is this from this order, UPSC has asked questions many a times in this NDA, CDS, as well as the CAPF exams. So this is a small component and process of the water cycles. Water stored in ocean. So what the process that they goes on: evaporation, evapotranspiration, sublimation, water and atmosphere condensation, precipitation, and so on. So these are the things that you can read your own and then uh, relate to what relate to the water cycle. So going with this, okay. So this is the same thing that 70% of the planetary water is found in the ocean. The remaining is ballast fresh water in glacier, ice caps, groundwater, lakes, soil moisture, atmosphere, and streams, and within life. We also, like we human beings and also the plants and animals have water, but they are in the lowest order of this decreasing order series of water in our atmosphere. So this is a different path. So relief of the oceans. Now coming back to the main topic of the chapter, that is relief of the ocean, the upper layer of the ocean, or the ocean floor, the upper layer. So as we have already studied about the relief of the outer surface of the earth, which is above the mean sea levels, and the landscape, as we know. So here we are going to read about the relief, the underground configuration of the land, like under the water configuration of land below the mean sea level. So the major portion of ocean is between 3 to 6 kilometers below the sea level. World's largest and the floor of the oceans are rugged, with world's largest mountain ranges, deepest trenches, and the largest plain. So, what are the biggest mountain chain over the earth? over the mean sea level, it is the Andes. Andes mountain range is the largest mountain range. Below the mean sea level, those are the mid-oceanic ridges, which are the largest mountain chains, and it has the deepest trenches. On our Earth, we don't have that deep trenches, but we have the deepest trench. For example, the Mariana Trench, Challenger Deep, that is around 10 kilometers, 9.9 something kilometers deep, which is higher than the Himalayan mountains also. And we have the largest plains in our under the water level, that is in our ocean. So let me show you how long is the largest mountain chain. Uh, so, mm, what is it? Which map? So this is the map of the mid-oceanic ridge. As you can see, this is the mid-oceanic ridge. Hmm, Let me take a clear picture. This is the mid-oceanic ridge. As you can see, this is a mountain chain, and it's the longest mountain chain of the earth. The Andes used to start from here and ends here. Okay, so there's a question for you. Just give the name of the countries in which Andes are located, and also name the volcanoes that Andes have, the Andes mountain range have, and what are the and like Cotopaxi is one of the thing, and what is the specialty of the Cotopaxi? There's a like, difference between other mountains and the Cotopaxi mountain, volcanic mountain. So let me know. So moving ahead, it has the largest plains also. So for the plains, we can see that the Ganga Yamuna plain, this plain is one of the biggest plains that the world has. And you can see that the plain like this Pacific Ocean plain, this is the biggest plain, and it is under the water in the oceans. So these are the longest, the biggest uh, plains that have. So oceans have both the longest mountain range and also the largest plains and also the deepest trenches. The mountains are also the Himalaya, the Everest over the Himalayas are also not that much high than the deepest trench that the uh, world has. The division of the ocean floors. The ocean floors are divided into four major divisions. The continental shelf, we will go deep later. Firstly, this is a definition what we are going to study. The continental shelf, the continental slope. Slope is a downward, as we know. Deep sea plains, the plains that we have just talked about, and also the oceanic deeps. Deeps, matlab, the trenches that we are going to study. Besides, there are many major and minor leaf features like hills, ridges, sea mounts, fjords, trenches, canyons, atolls, and other features. So we will read it one by one. Now, going to continental shelf. The continental shelf is the extended margin of a continent occupied by relative shallow seas and gulfs. It is shallowest part of the ocean, showing an average gradient of 1 degree. So, what is the point to be taken from this? Is that the slope is 1 degree or less than that. And it is the shallowest part of the ocean that has just emerged after uh, not immersed it is the like after when we go from beach to the ocean, and these are the first thing that we encounter, and these are the shallowest part of it. That shelf typically ends at a very steep slope, and when they end at a very steep slope, this is the most important part of the oceanic floor, which is very much responsible for the human life. So this end varies, and it varies from ocean to ocean. For example, the Arctic shelf is the largest shelf, but the shelf around the Chile and the south of the Indonesia, that is Sumatra, is absent, and they are the source of fossil fuel, and they have the thick sediments present because of the flow of the river, the outwash of the river in those areas. So let me show you how they are. So these are so this is the continental shelf. From here, the, this is land. It is mean sea level, and after that, this area is continental shelf, and this is continental slope, and this is abysmal plain that used to start later. So over the Google, let me show you. Yeah. We can see, we can see here. Okay. Oceanic deep. Let's see if we get anything related to what we are searching. Okay, so this in meters. Yes, search kit. Okay, great. So this is the map. So here we can see the mid-oceanic ridges here, here also. Mid-oceanic ridges are also visible. And what we are talking about is about continental shelf. So here, as we can see around like this area of India, we know Mumbai High and other petrol vessels, petrol exploration vessels have been set up here in this area. This because the continental shelves are rich in minerals and oceanic deposits brought by the oceans, brought by the sorry rivers and streams. And we can see here that the Arctic Ocean is the deepest. Arctic Ocean is the sorry, is the shallowest and biggest continental shelf. So this place has the largest continental shelf and the areas. So here you can see the color is changing abruptly to blue. So this is the area where the continent where the oceanic shells are smaller and the deep trenches arises here faster. And also here, uh, this is Sumatra, and after that there are deep. You see a sudden change from yellow to blue, from yellow to blue. So there the continental shells are absent. Now moving to the other topics of it. So let me see if anything. Source of fossil fuels, as we know, Mumbai, as you have seen, that those are not that much deep. Thick sediment presence. Okay. Now ocean flows. So sorry, continental slope. So continental slopes connects the continental shelf and oceanic basins. Continental slopes, it connects the continental shelf. This is the continental shelf. This is continental slope, and this is oceanic basins. So this is the thing that used to connect the continental shelf and oceanic basins. This is right, absolutely right. It begins where the bottom of the continental shelf sharply drops off into the steep slope. Okay, it begins where the bottom of the continental shelf sharply drops off into steep slopes. So where the continental shelf sharply drops and a steep slope is detected here. So this is the continental slope and the gradient is around 2 to 5 degree. The slope boundary indicates the end of the continents. Okay, so the boundary, this boundary, it shows that the end of the continents, this boundary. Okay, and and in this place, canyons and trenches are observed. Canyons and trenches are observed. So what are the things that we do out of it? That slope is 2 to 5 degree, and these are very sharp drops of the continental shelf, and these have canyon and trenches. Now, deep sea plains. So deep sea plains, or it is also known as abysmal plains. It is found at a depth of 3,000 to 6,000 kilometers. And there's a one more thing to note about is that the continental slope arises at a depth of 200 to 3,000 meters, whereas the deep sea plains are from 300 to 3,000 to 6,000 kilometers. They are present, and so clay and silts are present at the surface of surface. Fine grains, the grains are fine, and these have uh, three types of deposit. That is mud, ooze, and mm, mud, ooze, and clay. So these are the deposits that the deep sea plains have. But remember, these have the deposits, but the deposits are higher in the continental shelf. Okay, done. And the most widespread inorganic pelagic deposit on the ocean floor is red clay. Red clay is formed by volcanic eruptions. These are the clay that are originated from the volcanic eruption and are the oldest. Okay, so just giving a small definition, I haven't written it here. So there are three type of oceanic deposits found in the ocean floor. The first one is the mud. The muds are derived from the land and are mainly deposited on the continental shelf. They can be blue, green, or red in color based on the chemical properties of it. And the oozes. The oozes are the pelagic deposit because they are derived from the ocean organisms, from the shell or the skeletal of the microorganisms or organisms present in the ocean, and they are high in calcium and silica. And the clays are, as we know, that they are like clays are found in the deepest part of the ocean, and mostly they are made up of the volcanic dust. And the red clay is the most widespread in that. Now coming back, so I have covered this. Okay, oceanic deep or trenches. So what are oceanic deep and trenches? So these are the deepest part of the ocean. The trenches are relatively steep side and narrow. These are very the sides of this trenches are really deep, as we have seen in this image. This is not a good image. Let me find something much better. Hmm, okay, so we can take this as a reference. Okay, so oceanic trenches. They are some 3 to 5 kilometer deeps, and then surrounding ocean. Then the surrounding oceans, they are 3 to 5. Continental slope are around 3,000 to 600, 3,000 to 6,000 meters from the ocean shore, from the mean sea level. But these are 3 to 5 kilometers, then those means around 9 to 10 kilometers, they are deep. And they occur at the base of the continental slopes. They occur at the base of the continental slope. Okay, this is a surprising fact that continental slopes are not deep oceanic trenches are not found in the deepest part of in the mid of the oceans, but they are present at the continental slopes along the island arcs and associated with active volcano and strong earthquake because they are deep. And as you know that these are mainly found because of the uh, crushing of plates or the divergent boundaries formed by the plate. So these are most accompanied by earthquake and volcanoes. And uh, and the most of these plates, these oceanic trenches are found in uh, Pacific and in the lower Pacific, that is in the southern Pacific, in this part, mainly this part, because the upper part of the Pacific plate is convergent, and the lower part is divergent. So this is the reason. And the example of the some of the trenches: Mariana Trench, uh, Puerto Rico Trench, South Sandwich Trench, Java Trench. So your homework is you must Google these trenches and know where these are located over the Google Maps. Okay. So so moving ahead to minor relief features. Mid-oceanic regions is composed of two chains of mountains separated by a large depression. Mhm. Okay. The mountain ranges can have peaks as so these are the underground mountains that we have already talked about. Uh, these mountains that we have, these and these also, these are the mid-oceanic regions that we already talked about, and has a peak as high as 2500 meter, and some even reach below the oceans. Iceland's are part of the mid-oceanic regions. Sea mount. So sea mountains basically, as the name said, sea mountains. So these are the mountains that are pointed summits rising off the seafloor, and those does not reach the surface of the oceans. So these are the sea mounts that they rise of the seafloor, but they don't reach the upper surface of the ocean. So these are pointed. No, and there is gout also. Gout are the plateaus of the sea. So these are not these are also rising from the seafloor, but they are not that much steeper in the upper part. So these are the gouts. So seamounts and the gouts are only volcanic in volcanic in origin. Submarine canyons, deep valleys, as we know, also found at the mouths of the large rivers. For example, the river is flowing here, then they create deep trenches because of the friction and the load, traction load that that they're carrying. This is submarine canyons, deep flow, and are found at the mouths of the large rivers. For example, the Colorado River, Grand Canyon. This is not that much important as for the any of the UPSC exam, but just remember it, Grand Canyon of the Colorado. They are comparable to it, okay? They are not an example. Sorry for that. Gouts, as I told, sea plateaus, flat-topped sea mountains. They show evidence of gradual subsidence and stages to become flat-top because of the denudation process over of the hills. They turns to gouts, sea plateaus. Atolls, so these are found in tropical oceans. In the tropics only, these are found atolls and consist of coral reefs. These are found in the coral reefs. So what are atolls actually? Atolls are the mountains that are risen from the sea level, but have just uh, been over the ocean, not that much over the ocean. So those are the atolls. Those have lands just over the oceans. For example, the Lakshadweep archipelago is one of the examples of the atoll and consists of the coral reefs. It can be a part of lagoon or something from enclosing a body of freshwater Barkishan, highly saline water. Okay. Issue. This is an atoll island. This is an atoll island. Okay. You have also seen the images before this type of, these are the atoll mountains, just for a reference. Now, temperature of oceans. The temperature of oceans, what? So, what are the factors that are that affects the temperature distribution of ocean water? So, the first one is the latitude. So, as we know that when the latitude increases, the temperature decreases. The temperature of the surface of land or water decreases. So, this is also possible here. The equators are have a higher temperature. The water, ocean water at the equator is a higher temperature as compared to the pole because the insolation reached to the equator is high as compared to the poles. Now, the second thing, unequal distribution of land and water. Yeah, so there's another main reason is the distribution of land over land and water because the water that is surrounded by land has much higher temperature because land gets heated up more quickly than water. So the temperature of this area, this area that is not surrounded by land is higher. That this area is also higher as compared to the open ocean. This is a thing to be noted. Prevailing wind. So there are so the winds also takes away the water at the surface, which are warm in current due to the uh, sun's insolation. Due to the insolation and puts and the ground cold water that upwells up from the bottom of the surface. This also affects the temperature distribution of water, and this the latitude unequal distribution land water. This prevailing wind is the longitudinal variation in the temperature that is caused by the prevailing wind. No, ocean currents. Ocean currents also play a major role. As we know, the Gulf Stream, when they used to come, they used to form the eastern coast of the North America and the west coast of Europe. And the Labrador current, when they come, they takes the temperature of those areas to sub-zero sometimes. So ocean currents also play a major role in affecting the temperature distributions of ocean. The enclosed sea in the low latitude records relative higher temperature than the open seas. Okay, so in the lower latitudes, for taking example, for instance, the equator, uh, equator. Okay, what's it? higher temperature than the open seas. So this equator records higher temperature than the open seas because those receives much uh, insolation, whereas the enclosed in the high latitude have lower temperature than the open seas. So this is the reference to the open seas. Okay. So and in the higher latitudes, as we know, the insolation is low, so land is much cooler. Land area is much cooler than the sea, and because of its contact with the sea, the land's contact with the colder land contact with the hotter sea, the sea becomes cooler in the higher latitudes. So now moving ahead, horizontal and vertical distribution of temperature. So we have read about the horizontal distribution in somewhat reference to what we have read after this. After this, so vertical distribution we are going to see. So the temperature depth profile of the for the ocean water shows how the temperature decreases. So how the decreases from the surface to the bottom. So this is the vertical distribution that we are going to read about, and there is a thermocline boundary. So is there any? Okay, so this is the graph that we can take as a reference. So average temperature of the sea of the oceans is around at the surface is around 20 to 24 degrees Celsius, 25 degrees Celsius. But and as we go down, so there's not much that much change in not that much change in the temperature. Temperature is same as we go down. But at some point around 400 to 500 meters down the MSL, we see there is a sharp decrease of the temperature, the sharp decline of the temperature. This point is called the thermocline. And after a sharp decline in the temperature around 4 degrees Celsius, uh, this decline goes not that much steep, and the temperature gradient becomes lower. So this is the temperature, vertical temperature distributions, and so now going to the mid latitude and low latitude comparison. So this can be the temperature structure of ocean over the mid and lower latitudes can be described as a three layers. So this can be divided into three layers. The first layer has 500-meter thick. So the first layer, this one, is 500-meter thick, and the temperature is around 20 to 25 degrees Celsius. This and 20 to 25 degrees Celsius, the first 500 meter, as we have seen in this graph. The second layer was thermocline layer. This is the layer where the temperature falls abruptly. Uh, so from 500 to 1000 meters, the thermocline level and the temperature rises from 20 degrees Celsius to 4 to 5 degrees Celsius abruptly in a range of 500 meters, 5 to 600 meters. Okay, and the third layer, the deep ocean flows, where the temperature is normally around 0 degrees Celsius. And water at depth at 0 degrees Celsius is not ice because salt concentration decreases at freezing point from 0 degree to minus 2 degrees Celsius. The temperature here reaches around 0 degree at depth, but they don't convert to ice because salt concentration is higher, which takes the freezing point of water from 0 degree to minus 2 degrees Celsius. Okay, and like in the Arctic and Antarctic, the surface temperature of water is close to 0 degrees Celsius, and so there is not that much change in the with the depth as we go down in Arctic and Antarctic only. Now, horizontal distribution. So the average temperature of surface water of ocean is of 27 degrees Celsius, as we know. And we go from equator to poles, the temperature starts to decrease because of the insulations that received by the ocean. The rate of decrease it is around zero point 0.5 degrees Celsius per latitude. The ocean in the northern hemisphere records relatively higher temperature. The northern hemisphere, because the land area is higher in the northern hemisphere, because of which they record relatively higher temperature than in the southern hemisphere. The highest temperature is not recorded at the equator, but slightly above of it to the north, because the land is much located over the northern side. So, because of its contact with ocean, the higher land contact with the ocean, the temperature of the ocean rises. Okay, so is the larger north of it? Okay. Okay, so this has already been when it's well known the maximum temperature of the ocean is always at the surface because they deceive that okay. This is indicating temperature. This is the same thing that I have explained. Salinity of ocean water. Now we have what we have read till now. Just we have read about the hydrological cycles, just an overview, and then we have gone to relief, continental shelf, continental slope, continental yeah, deep sea plains and the oceanic trenches. Then we have got mid-oceanic ridges, sea mounts, submarine canyons, gayouts at all. We have seen the factors that affects the temperature distribution of oceans. We have seen the vertical distribution and also we have seen the horizontal distribution. Now moving ahead to the salinity part of the ocean. What is the distribution and salinity of the ocean and what are the factors responsible for it? So salinity is term of the total content of the dissolved salts in seawater. It is has been calculated as parts per thousand, not parts per million. It is written in this form. Salinity, the average salinity is around the 24, 25 of the seawater. The brackish water salinity type has been considered. Okay, so this is 24.7 is the upper limit to demarcate the brackish water. What are the factors affecting ocean salinity? Look, let me just check what is the average salinity of ocean. It has been written somewhere here. Uh, Average salinity of ocean water. Mm, Average salinity of ocean water. It is around 35 per parts per thousand. Okay, 35 per parts per thousand and 24.7. This is the horizontal distribution of salinity. Okay, so copyright आ जाएगा. Okay, we can take this as a reference. 24.7 is the upper limit of salinity, and you can see that in the ocean there is nowhere a big whole the ocean is brackish in nature, brackish water as per this, and the average salinity is around 35 of the ocean water. So what are the factors that affects the salinity? So the salinity of water in the surface layer of the ocean depends mainly on evaporation and precipitation. The more the evaporation, the higher will be the salinity because water amount decreases and the salt amount increases. Salt amount in relation to that also the salinity increases. Okay, and surface salinity and the precipitation with the when more water comes in, then the salinity decreases. So this is one relation. The surface salinity is greatly influenced in the coastal region. When the fresh water flows down, then the concentration of water increases because of which the salinity decreases. So this is also a reason. And polar regions process of freezing and thawing of ice. Okay. Wind also influences salinity. Transferring when wind flows, then used to transfer water from one region to another. Because of which, when a new ocean current comes, then according to the salinity of the water that the ocean current has, the and where they reach, the salinity increases or decreases. For example, when the ocean comes from this area, when Labrador current comes, for example, in this area, then the salinity of this area decreases because they take up low salinity water. And when the Gulf Stream goes from this area to this to upper areas, then the salinity increases because they are carrying much salt concentration to these areas. So the ocean currents contributes the salinity, temperature, and density of water are interrelated. So salinity density. So higher the salinity, higher will be the density of water, and hence any change in temperature or density. So as you know that when temperature increases, the water also gets the water quantity also increases when temperature increases because water also takes up much area. And this is also a reason because of which the ocean currents uh, flows. Uh, the increase in the volume of the water, the lower will be the salinity. So and vice versa. So these are the things that affects the ocean salinity. These are the places of the highest salinity or highest saline water bodies. First is the Lake One, that's 330, then the Dead Sea, and then the Great Salt Lake. These are the other areas that I have marked. One Lake, it is here. Dead Sea, it is located here in Israel. It is in Turkey, it is in Israel. Pangong, so, and Great Salt Lake, so it is here. And in India, we have Pangong, so here in Ladakh. Somoreri also just lower of it in Somoreri in Ladakh or in Himachal. Somoreri. And this is the Sambar Lake, that is the highest saline lake in India. It is located in Rajasthan, west of Jaipur. Oh, okay, Somoreri mountain lake in from lake. Okay, it is related. It is located in Ladakh only. And freezing of point of height is inversely proportional to salinity. Okay, isonif, isonif, it's the line that connects the equal snowfall areas. Isohel, the line that connects the areas getting the sunshine, gets the equal sunshine at equal time. And isohypes are the same height. For example, the contour maps are found by isohypes. What is contour map? Let me show you. This is really helpful for me when I explore on the Google Maps. Just cross it. This is the contour maps. Okay, this is the contour maps. So, for example, this is Kanchenjunga. As I zoom in here, so these are the ISO heights. And what are the ISO heights? Tell me in the comment section. Okay, so I have covered all the extra points also. And now horizontal distribution of salinity. So the salinity for normal oceans ranges between 33 to 37, 33 and 37. As we know, 35 is the average salinity, 35 parts per thousand. In the landlocked Red Sea, it is 41 parts per thousand, while in the estuaries, it fluctuates from zero, like in Arctic, from 0 to 35 uh, seasonal, seasonally. Okay, because of the high flow of water, the salinity decreases in that area. The salinity variation in the Pacific Ocean is mainly due to the shape and larger areal extent. Salinity decreases from 35 to 31 on the western part of the northern hemisphere because of influx of melted water in the same way after 1520. Okay, so let's take this salinity. Okay, so salinity in the western part decreases. The western part of the Pacific Ocean because of western part of the Pacific Ocean. So here salinity is lower because of the high influx of the sea, Yellow Sea, and there are also many sea that used to put out the water here in the western part. And the average salinity of Atlantic Ocean is 36. The highest salinity is recorded on 15 to 20 degree mid latitude. Okay, and, 20, and the maximum salinity. So we can see here in the map that the Atlantic Ocean is the highest saline ocean out of the five oceans that we have. It gradually decreases towards north. North decreases because this Arctic has less salinity, and this is the salinity gradient that we can see. The North Sea, in spite of its location high in latitude, records higher salinity due to more saline water bound by North Atlantic. So this is the North Sea, and this sea, being in the northern hemisphere, in the upper northern hemisphere in higher latitudes, because of the Atlantic, the Gulf Stream, this area got higher like high water from the mid-Atlantic region, and the higher saline water, because of which this area has higher salinity. The Baltic Sea records lower salinity because of the influx of water. This area has lower salinity because a high influx of rivers. Sweden is a country of lakes, so lakes used to put the waters here by small streams. The Mediterranean Sea records higher salinity due to high evaporation. This part you can see that salinity is high because of the higher evaporation of water, as they are much surrounded by land area. Salinity is, however, low in Black Sea due to enormous fresh water influx by rivers. The Black Sea here. Let me show you over the map. So this is the Black Sea here because of the various rivers. For example, the Dnipro River that has been in the news during the Russia-Ukraine war. Zaporizhia. This river used to influx water here. Various rivers also influx water from Turkey, from these hills, and also from Romania, Bulgaria. So, because of this high influx the Black Sea has lower concentration of salts, low salinity, and the low salinity is observed in the Bay of Bengal. The Bay of Bengal also have high influx of water due to the Ganga Brahmaputra basin here, and also from these areas also, Narmada, Tapi, Krishna, Kaveri, Godavari. So, uh, because of which salinity is low in Bay of Bengal as compared to the Arabian Sea, because they have low influx of water and high evaporation because they are not surrounded by the land. A vertical distribution of salinity. So salinity changes with depth. By the way, it changes depends on the location of the sea. Okay. So for example, this the it also has the same graph that we have. This is the as we go down. So salinity there not that much decreases, but as we go down much down, then there is a halocline level where the salinity decreases abruptly, and after that, it constantly decreases. So this is the low latitude. On the low latitude, this is because over the low latitudes, we know that low latitudes means this area, the salinity is already high. So as we go down, the salinity decreases. But in the high latitudes where the salinity is lower, and over the surface, the salinity is lower than what it is at the bottom. So this is the graph alpine level. Sorry, vertical distribution salinity. Means in lower latitudes, as we go down, the salinity decreases, while higher latitude, as we go down, salinity increases. This is the uh, s- map of the surface salinity, distribution of salinity over the world map, world's ocean. So salinity at the surface increases loss of water or decreases the input of fresh water, such as on the river. Okay, same thing. Salinity at the depth is very much fixed. At the depth, they are much fixed, as you can see. This is the point. Okay, this is the salinity that at the depth it is almost constant at every place, but at the upper level it varies. Okay, and there is much different salinity. The lower salinity water rates above lower salinity. Okay, so what happens here is that the when the water gets more salinity in it, uh, like this water have more salinity than the lower one, then the upper water has higher density, the water used to go down, and the upper water with lower density, that is low salinity, used to get up. So this is what is written. The lower salinity water rest above the higher salinity dense water. Salinity generally increases with depths, and there is a distinct zone called halocline where salinity increases sharply. Other factors being constant, increasing salinity of seawater causes its density to increase. High salinity seawater generally sinks down below the lower salinity water. This leads to stratification by salinity. So this is what I've already told, in, I have described here, and also here too. Now, coming to this exercise, so identify the elements which is not a part of hydrological cycles. So what is evaporation? precipitation, condensation, evaporation of the sea, oceans, so that to form clouds, precipitation from the clouds, and condensation for like the water vapor is to condense to, and then precipitate sugar. So hydration. Hydration is not radio. Hydration is the amount or the number of water molecules that element or a molecule can have. For example, CuSO4 can accumulate 10 H2O, that is hydrogen molecules. This is hydrogen that is not related to hydration. The average depth of the continental slope varies between continental slope. This is a question. Okay, so it is around 200 to 2000 meter. This is the right answer. Which one of the following? Okay, from this we can relate. The continental shelf is around 200, 500 meters, and the slope is 200 to 2000 meter. And for the continental, mm, so deep sea plains that are around 3000 to 600 meters. Which one of the following is not a minor relief feature of the ocean? Minor. Okay. Ocean deep atolls, sea mountains, guyot. So sea mountains, atolls, and guyot are the minor features, but ocean deeps are the major features. Salinity is expressed as the amount of salt in grams in sea per what? 10 gram? No. 100 gram? No. 10,000 gram? No. Parts per thousand. So 1000 gram. Which one of the following is the smallest ocean? Indian? No. Atlantic? No. Pacific? No. It's the biggest ocean. Arctic. This is the smallest ocean. Why do we call so? These are the questions that you can attempt on your own. For just adding some questions, adding some points to it. Freshwater quantity. So highest freshwater quantity is in glaciers and mountains, then groundwater, then rivers and lakes. This is the trend. This is the order. Sargasso Sea. So mm, Sargasso Sea is famous for anticyclonic circulation of ocean currents. Highest salinity in the Atlantic Ocean forms Gyre. Sargasso formed by North Atlantic Current, Canary Current, and North Atlantic Utility Current because when they meet at each other, so they form a great fishing ground there. And Sargasso Sea are not that much deep; they are shallow, because of which they can form plankton and fishes are there. Sargasso Sea also an area where the Titanic has sink had sink. This is the complete chapter Water and Ocean of Physical Geography Class 11. I have also covered the MCQs as per the UPSC, which I have written here in the points, which UPSC have already asked. Hope it helps you. Have a good day. Thank you.